Hello students, welcome to the third session of CBSE class 10, chapter real numbers. Today our topic is irrational numbers. So what is irrational numbers? The definition is the numbers which when expressed in decimal form are expressible as non-terminating but non-repeating decimals are known as irrational numbers. For example, you can have 0010. This is a non-terminating, non-repeating number. And then we have this square root of any non-perfect square number like square root 3, square root 7, square root 10, and so on, or cube root of any non-perfect cube number. Like 4 is not a perfect cube number, so if you do the cube root you will be having a non-terminating decimal representation, and it will be non-repeating also. So what kind of problems we have here? We have something like you have to prove that, say, root 2 is a irrational number. Okay, so question is, prove root 2 is irrational number. So let's try to prove it. Okay, we can do it actually two different way. The first way is we can do it just by long division method, and in that case find uh, we have to find after decimal at least 6 or 7 places, which is little bit difficult obviously. So that's why we are doing in a theoretical way. The rule is we are using the contradiction method. That means whatever we need to prove, we will assume exactly opposite of that. So we will write let root 2 is a rational number. Though we need to prove it's a irrational number, but as we are doing in the contradiction method, we are taking root 2 is a rational number. Okay, as root 2 is a rational number, according to the definition of a rational number, root 2 can be represented in the form a by b, where a and b both are integers, b not equals to 0, and a and b are co-prime. So it's very much important that you should write that a and b are co-prime. Okay. Okay. So this is the most important line we should write while doing this contradiction method, that a and b are co-prime. Okay. So let's take root 2 equals to a by b. Now what we can do, we can square it both sides. So 2 equals to a square by b square. Now the a square will become twice of b square. Okay, fine. Now if a square, we can see it's divisible by 2. So we can write now a square is divisible by 2, because a square is having an factor 2. In this, if a square is divisible by 2, a is also divisible by 2. And if a is divisible by 2, you can simply take a equals to twice of m, where m belongs to set. That means m is an integer number. Okay, and we're gonna replace that a here. So let's try that. It will be 2m whole square equals to twice of b square. From here you can definitely write b square equals to 2m square. The b square is equals to 2m square. Okay, that's what we have. B square equals to 2m square. Now what happens? If b square equals to 2m square, that means b is also, sorry, b square is also divisible by, then b is also divisible by 2. Okay, so we can see as per our we can see as per our calculation that a is divisible by 2, b is divisible by 2, but it's in contradiction. Contradiction to what? It's a contradiction that a and b are two co-prime numbers, but we can see that a and b having two common factors, that is 2. So it's actually not possible. Hence we can write, as it's in contradiction and then our initial assumption is wrong, then root 2 is not a rational number, it's a irrational number. Okay, it's not a rational number, it's a irrational number, because it's giving me a contradiction that a and b, we initially have taken this is an co-prime number according to the definition of a real number, but we can see it is having two a common factor other than one, that is 2. So it's technically it's wrong. Okay, okay, one other type of questions we can have, this is the basic type of questions we have, that you have to prove something is a rational number. And the other kind is two that is the, in this case we have a single number which we have to prove it's a irrational. Other than that, we have some questions like, say we have a question like, prove that root 2 plus root 3 is a irrational number. Okay, so that means we have a combination of two irrational numbers. So how we can do it? We will be doing it in a contradiction method. So we will write, let root 2 plus root 3 is a rational number. Then what we can do, we can just take the root 2 plus root 3 as a, okay, where a is a rational number. Okay, then we will try to get the value of root 2. So the root 2 will be root 2 equals to a minus root 3, and then we will be squaring the both side. Okay, so root 2 whole square equals to, sorry, a minus root 2 whole square. So 2 equals to a square plus 3 minus 2a root 3. We should always write down the formula as a side note. So we are using this identity, a minus b whole square equals to a square plus b square minus 2ab, to get the a square plus 3 minus 2a root 3 part. We always should write it down. Okay, now we should try to get the well value of the irrational number root 3, that is equals to, if I calculate, a square plus 1 by 2a. Okay, now this a square plus 1 by 2a, this part is what? This part is a rational number. Why rational? Because the a itself a rational number, and a square plus 1 by 2a, obviously it will be a rational number. So this is a rational number, as a is a rational number. We should put that there also as a side note, that here my a is a rational number. So rational, as a is a rational. But this root 3, we already proved it, it's an irrational number. Now this is actually impossible, that the left side we have a irrational number and that's exactly equal to a rational number. It's impossible. In no irrational number cannot be equals to a rational number. So hence we can write, as our initial assumption is wrong, so it's in contradiction, it cannot be a rational, so root 2 plus root 3 is irrational. Okay, so hope you have enjoyed the video. Thanks for watching. Please do like, share and subscribe me for more videos. In the next video we'll be doing the polynomials. So that's the end of our first chapter. We finished it within 3 sessions. Okay, for anything else you can write down that into the comment section.